Okay, so let's start. For the log, the most important thing is my circle. So let's do the log form to exponential form first. That's the easier direction, right? So start from the base. The base is 3 here. Go to the fifth power. And then you come back is x, right? Is x. So the corresponding exponential form is 3 to the fifth power is x. Okay, is x. So 3 to the fifth power is 243, but we are not solving x here. We don't need to know that. Okay, you need to write down the new equation in the power form in the exponential form. So now same thing here, base is 2. So we start from here. 2 to the x power is 3, right? Is 3. So that's the exponential form. Okay, exponential form. So now for the first question, right? For the first question, okay. So first base is 2. So we know log, we have the same base, right? So we have log 2. And then 4 and 16. Okay, 4 and 16. So if you don't know which one is inside log, which one is on the other side of the equation, you can try it, right? You can try it. So you have log 2 of 16 is 4. Or the other choice is log 2 of 4 is 16. So which one is right? You can use my circle to check it, right? 2 to the 4th power 16 looks good. 2 to the 16 power is 4. That's wrong. So this is the wrong one. Okay, this is the wrong one. So this direction from exponential form to log form, if you can remember, this is log of the base, and this is the power of the power is equal to exponent. Log essentially is the exponent. Then you can do it, right? If you can't, make sure the base is in here, and then you have two choices for the other two, and then check it using my circle. Okay, yeah. So one more thing about log is the base has to be positive, and then power has to be positive, right? So later in the equation part, we need to check after solve x for the linear quadratic equation. You have to check whether inside the log is still positive, right? Inside the log is still positive. The exponent could be positive or negative. Only this one could be negative. Okay, that's the first question. So the next question, we want to find log 3 of 1 over 27. Right, 1 over 27. Okay, yeah. So I'm going to solve this in two different ways, right? Two different ways. So first, we use my circle. So 3 to the x power is 1 over 27. Now 1 over 27 is negative power, right? You list negative power of 3, negative 1, 1 over 3, negative 2, 1 over 9, negative 3, 1 over 27. So this is the one we want. So 3 to the x is 3 to the negative 3's power. Cancel 3, you got x is negative 3, right? X is negative 3. Okay, yeah. So use the circle, you can solve this, right? You can solve this. So we can also use formula 2. So what's formula 2? We have 3 same base formula and 1 change base formula, right? So formula 2 is about the division of powers, right? Division of powers. So this will be subtraction of the log. Okay? Yeah. So now if you use this one for the question on the left, what do we got? Log 3, 1 over 27. So this is log 3 of 1 minus log 3 of 27, right? And this will be 0 minus 3, negative 3. Okay, negative 3. So we got the same answer. This is negative 3. Okay, negative 3. So now for number 5, right? For number 5, for the question on the right, so let's use this formula because that's a much harder one. It has radical and it has division, right? And it has that division. So log 2, now let's solve this one, right? Radical 2 over 8. So this is log 2 of radical 2 minus log 2 of 8. Okay, so now what's log 2 of radical 2? 1/2. What's log 2 of 8? 3. So this is negative 5 over 2 or negative 2.5. Okay, negative 2.5. Okay, yeah. So now if you are not familiar with radicals or why log 2 of 8 is 3, you can use my circle, right? You can use my circle. So log 2 of 8 is x, so 2 to the x is 8. and 8 is 2 cubed, so x is 3, right? And log 2 of radical 2 is y, so 2 to the y is radical 2. So radical 2 is half power. That's definition of rational power, so you got y is 1 half. So this is 1 half minus 3, right? 1 half minus 3. Okay, yeah. So if it's multiplication, is the addition of multiplication of powers is addition of log. Here is subtraction of log is division of powers. Okay, division of powers. Okay, so later we will have a list the same base formula and change base formula, right? 4 formulas. So the whole log is 4 formulas and a circle. Okay, and a circle. Okay, so now the next question is the graph question, right? Graph question. So this is the easier one. We pick x, right? We pick x to be 2, 1, 0, -1, and -2. And then we find f of x, comma f of x give you a point, plot the point, you got the graph, right? You got the graph. So this is f of x, which is 2 to the x plus 2's power. So this is f of 2, this is 2 plus 2's power, 4's power, 16. F of 1, so this is 1 plus 2's power, so 2 to the third, 8. F of 0, 0 plus 2, this is 4. F of -1, this is 2 to the -1 plus 2, this is 2 to the first power, 2. F of -2, this is 2 to the -2 plus 2, 0 power, 1, right, 1. So now we make the point. Okay, so we pick x here, 5 values, and then this is the 5 points, right, 5 points. So this is 2, 16, this is my A, 1, 8, this is my B, 0, 4, point C, -1, 2, point D, and -2, 1, this is point E, right, point E. So now let's plot the point, right, plot the points. So E is -2, 1, so this is 1, 2, so this is -2, -1, so E is here. Because we have 16, so we don't want to use the same height, okay, same height, same unit on x or y axis. So this is my E, D is -1, 2, this is D, and C is 4 on the y axis, and then B is 1, 8, this is 1, this is 2, and then A is 2, 16, right? Okay, A is 2, 16. So you plot the point and then draw a curve, good curve connecting them, you got the graph, right? You got the graph. Okay, yeah. So we pick x for the exponential function, okay, pick x for an exponential function. So for the log, we will pick log, okay, graph of log. Okay, so f of x is for the log function. We will pick 5 numbers here, the output, right, the output. Okay, so we want log equals +2, -2. So let's start from positive number, right? Log is 2, log is 1, log is 0, log is -1, and log is -2, right? We pick log to be the integers, right? To be the integers, and then use what? And then use my circle, right? And then use my circle to solve for x, right? So this is 3 squared is x minus 1, x is 9 plus 1, 10. This is 3 to the first power is x minus 1. So x is 3 plus 1, 4, right? And this is 3 to the 0 power is x minus 1. So now it's 1 plus 1, x is 2, right? X is 2. And this is 3 to the -1's power, okay? 3 to the -1's power. So That's 1/3, right? 1/3 is x minus 1, so x is 4/3, right? 4/3. And then the last one is 3 to the negative 2's power is x minus 1. So what's negative 2's power? 1/9 is x minus 1, so x is 10/9. Okay, 10/9. So this is the x part. X part is harder, so we pick log sub x, right? Sub x. Okay, so now let's write down our 5 points. So what's point A? Point A is x is 10, log is 2, right? Point B is 4, 1. Point C is 2, 0. Point D is 4/3, 1. Point E is 10/9, negative 1, negative 2, right? Negative 2. Okay? Yeah. So now we mentioned the log, the domain a little bit. So we cannot take log of negative number, right? So x has to be greater than 1. Okay, greater than 1. So now if you look at the graph, x equals to 1 will be a vertical wall. So this is the vertical asymptotes, right? You cannot draw anything beyond this wall, right? So the domain of x is here. So the whole curve is on the right side of this wall, right? Right side of this wall. Okay, so now let's plot the 5 points. So where is A? A is 10, 2. So this is 10, 2. And B is 4, 1. So here is 2. B is 4, 1. I don't have space to draw 10, so let's keep A in the screen, right? So the picture is not that accurate, not that good. Okay? Yeah. And then this point C is 2. And there's 3/4, negative 1. So this is D. And then 10/9, negative 2. E. Okay? You can see from A, B, C, D, E. So it's approaching to vertical wall, but never touch it. Let's go down to negative infinity. Right? Go down to negative infinity. Okay? Yeah. So that's the graph of log. Okay, graph of log. We pick 5 values for f of x for the log. Okay? Yeah. So that's the graph.